Hello everybody, welcome back to another week. This week we're covering chapters 10.3 and 10.4, so let's go ahead and check out some example problems here. First off, we're going to check out 10.3.38, which is number 1 from your 14th homework assignment. Now, we're told that the results of a paired difference test are the sample difference is negative 2.7. The sample standard deviation of the differences is 0.25, and then the sample size is going to be 16. And we're asked to construct a 99 and a 90% confidence interval for the difference between the two, for the difference between the population means. All right. So as you know, or as I talked about in the video, the confidence interval is given by this formula right here. You take your average difference, add and subtract a t-value. Now, this is going to be a t-value rather than a z-value because it's based on a sample standard deviation. Again, though, it's the sample standard deviation of the differences. And then, once again, multiplied by same kind of deal, sample standard deviation divided by the square root of the sample size. All right. So for the 99% confidence interval, of course, we're given the sample difference is going to be a negative 2.7. So negative 2.7. Bring down the plus or minus. Now the t-value. The t-value is, of course, based on our degrees of freedom, and degrees of freedom is based on our sample size and our confidence level. So since our sample size is 16, our degrees of freedom is going to be the sample size minus 1, or 15. So you look at the degrees of freedom of 15, and for the 99% confidence interval, I come up with a t-value of 2.9467. Then, of course, pretty straightforward. We're given the sample standard deviation for the difference is 0.25. Divided by the square root of the sample size, which was again 16. Now, of course, you're going to get a lower and an upper bound again for this confidence interval. The lower bound is you take the negative 2.7 and subtract this quantity, and then the upper bound, take negative 2.7 and add that quantity. So for my lower bound, I end up with negative 2.88, and we know that's going to be, well, we don't know, but we're going to be 99% confident that that is less than or equal to the actual difference between the population means, which is less than or equal to negative 2.52. Next up, of course, the only thing that changes here is our t-value, because now our t-value is based on 15 degrees of freedom and a 90% confidence interval rather than the 99%. So only thing that changes is our t-value right here, and when I looked that up, I got 1.7531. So again, we have the mean difference, which was negative 2.7, plus or minus the t-value, which was 1.7531 again in this situation, multiplied by our sample standard deviation of the differences of 0.25, divided by, again, square root of the sample size, which is 16. In this case, it comes out to negative 2.81 is less than or equal to the difference between the population means, which is less than or equal to negative 2.59. So again, pretty straightforward, pretty similar to calculating confidence intervals just for a population mean. Only difference is basically now we're talking about a difference between two population means rather than just one population mean. All right, let's check out another example from 10.3. We're going to do 10.3.40, which is just your next problem or your second problem from the 14th homework assignment. So let's go ahead and read the problem statement first, determine what it's asking us for. Paired sample study has been conducted to determine whether two populations have equal means. So we're going to see if there is a difference between the population, basically, because we want to see if they are equal or if there's a difference. 30 paired samples were obtained, so our sample size is 30. The sample results were a sample mean difference of 9.65 and a sample standard deviation of the difference of 14.0. And then we're asked, based on these sample data and the significance level of 0.05, what conclusions should be made about the population mean? Now, you may notice this problem, it asks you basically for a p-value rather than a t-critical value. Once again, on an exam, I'll never ask you guys for a p-value. Again, a p-value is just another way of testing a hypothesis. Using the t-critical value is absolutely identical. I just like to use that method over and over again to keep things consistent. But after I go through testing this hypothesis with a t-critical value, I'll go back and show you guys how to find the p-value too. Alright, so let's go ahead and get started. Once again, when I'm testing hypotheses, I always follow those 5 steps I outlined for you guys. Step number 1 again is determine what you would like to show or prove. Use this to set up your null and alternative hypotheses. So what we want to determine is if the two populations have equal means. So our null hypothesis is that the difference is equal to 0, and then our alternative hypothesis is just that the difference is not equal to 0, of course, then. If, for example, it said that population 1 was greater than the other, then this might be greater than, equal to 0, that type of situation. Alright, step number 2, of course, we were told the significance level is 0.05 or 5%, so I just identified that. Step number 3, identify your critical value and use this to identify the rejection region. Now, once again, since this is based on a sample standard deviation, instead of using a z-critical value, we need to use a t-critical value. And the critical value is, again, just based on the degrees of freedom, which in this case is going to be 30 minus 1 or 29. So 29 degrees of freedom and the 5% significance level. I look that up in the t-critical table and I get 2.0452. Now this is a two-tailed test because we had a hypothesis of equal to, not equal to. So of course we're going to have a positive and negative t-critical value. So I just identified our rejection region here below. Negative 2.04, positive 2.04. Now step number 4, calculate the test statistic. Once again, since this is a t-test, we're going to calculate out a t-test statistic value. We have the formula right here, which is our sample difference mean, which was 9.65. Subtract out now our hypothesized difference. Our hypothesized difference was 0, so plug in a 0. And that's all divided by the standard deviation of the difference between sample means, or 14, divided by the square root of the sample size, in this case 30. And I get a t-test statistic of 3.78. Now, of course, 3.78 would fall somewhere right around there. So that is in the rejection region. So my decision then, of course, is to reject the null and accept the alternative. So if you want to say that in a sentence, we can be 95% sure, which is just 1 minus the significance level. So we can be 95% sure that the mean difference is not equal to 0. So we can just be 95% sure that there actually is a difference between those two population means. Now, let's go ahead and answer the questions they actually asked you for your MyStatLab homework. Question number, or part 1 was just to identify the null and alternative hypotheses. Of course, that was our step 1 right here. Step number 2 was to identify the test statistic. That was our step number 4 over here. Ours was 3.78. Now, identify the p-value. If you want to figure out the p-value when it's a z-value, or sorry, when it's a z-test, it's pretty easy. You can just look it up in the standard normal distribution table. But the thing is, we're only given certain critical values when we look things up in the t-distribution. So if you want to find a p-value based on a t-distribution, you're always going to need to look it up online for, well, at least for this class you are. Once again, you're never going to be asked for a p-value on an exam. So in just a second, I'm going to bring up the computer screen and I'll show you guys how to find the p-value online. But before I do that, let's just answer the last question. State the conclusion about the hypothesis test. Of course, we reject the null hypothesis, and there is sufficient evidence at the 5% significance level to conclude that the population mean paired difference is not equal to 0. Alright, I just want to show you guys real quick how to identify the p-value that related to our test statistic of 3.78. So, once again, all that a p-value is just the probability of obtaining a test statistic as extreme or more extreme than the test statistic of interest. So to do this, once again, you're going to need to look it up online because you can't figure out a p-value from a table when it's based on a t-test as you can when it's based on a z-test. So what I've done is I just go to Google and I've Googled p-value from t-score calculator. Go ahead and select that. And the first one right here on the list is quick p-value from t-score calculator. Click on that one right there. Now, first box right here is the t-score. Our t-score again was 3.78. Down here it asks us for DF, degrees of freedom. Our sample size was 30, so again our degrees of freedom was 29. The significance level, we were asked to test this at the 0.05 significance level, and since our hypotheses were equal to, not equal to, this is going to be a two-tailed test. Now, just calculate this out, and let me zoom in here. Sorry. So we got a p-value in this case of 0.000725. Rounded to 3 decimal places, of course, you'd round that to 0.001. Now, what that means is that the probability of getting a test statistic of 3.78 is 0.000725, or about 0.075%. So, because that p-value is less than our significance level that we're testing the hypothesis test at, again, our decision is the same. We reject the null and accept the alternative.